Welcome to the cLab Pirate Radio. I'm Anna, a co-host of another podcast called Zero Knowledge Podcast, and I'm here today with Connor and Anna Carroll. Hi, guys.
Hey there.
Hey, y'all.
I think we should start off, quick intro to what you're working on. What do you do?
Yeah, I'm a protocol engineer working on Optics, which is a cross-chain messaging protocol that we'll be talking about a little bit more today.
Yeah, and I'm an infrastructure engineer doing the same thing, building blockchain infrastructure for our whole stuff that we got going on.
Okay, cool. So let's find out about Optics. What is Optics?
How do you take that one? Yeah.
Optics is a standard for passing messages across chains, essentially. So it's a new design that enables interoperability between different blockchain networks.
Would you call it a bridge? Is it a type of bridge? Is it a...
It's not exactly a bridge. What we're building is a communication channel that allows you to connect multiple blockchains and messages between them. You could totally build a bridge on top, but you can build a lot of things.
So it's kind of like, it's not the bridge itself, it's something below the bridge. A protocol for bridges?
Yeah, communication layer.
Okay.
It could be for bridges. So yeah, exactly as you said, it's that messaging layer that passes information between chains. And what you can do is build on top of it any type of application. What a token bridge is what I would call a cross-chain application. Mm-hmm. And you can build a variety of different types of cross-chain applications on top of Optics. However, the token bridge is going to be the first cross-chain application, or ZAP, XApp. That we're going to deploy on Optics.
I want to sort of expand on that idea of messages, though. So, like, token bridges, I think we somewhat understand, but is there another thing that could be used across here? Like, would an application be able to talk to another application without any token transfer over something like this?
Yeah, absolutely. So, so the talk that I'll be giving actually on Wednesday is going to be a cross-chain developers workshop. So it's going to be unpacking sort of the anatomy of a cross-chain application, what this looks like, how we use Optics as a generalized message passing layer to build applications on top of it and do interesting things in a cross-chain environment. Cool. But essentially, if you can think about like, two smart contracts talking to each other within the context of a single blockchain, in order for a smart contract to interact, it just sends a transaction, which triggers code at the other contract. You can basically think of this as the same thing, but in a cross-chain environment. So instead of sending a transaction, you would send a message across Optics, which is, again, that messaging standard.
Can we I want to picture sort of like maybe an existing application and how that could potentially work here. Would it be something like the storage is over here and the execution is over here, or is it something like execution and execution? Maybe for some reason broken down into two chains.
Yeah, absolutely. So basically, the way that I've been building cross-chain applications on top of Optics has been essentially implementing this pattern I'm calling like a router pattern. And basically, each router does the same thing. What it does is it standardizes a messaging format that routers on other chains can understand. Cool. So when you trigger a transaction on the router, it will encode that information into its messaging format, send that message across chains. On the other side, that router will have the same piece of code, decode the message. Mm-hmm. And depending on the type of application, there's a sort of application logic, business logic implemented on the sending side, the receiving side, or both.
Cool. Is there some application in mind that you have? Like, is there a Uniswap or is there something that you're thinking about in designing this? Or is it, I know it's very general, but I'm almost curious if we could walk through what that might even be like.
Yeah, we're really kind of excited on bringing as much as possible as we can to the Celo ecosystem.
Yeah.
So just enabling people to, build new tokens, bring their existing tokens from other remote blockchains. Ethereum being one big one that we're focusing on right now. I don't know if you have a different perspective there.
Yeah. No, I think Optics is intended and designed to be as generalizable, flexible as possible. Mm-hmm. So it's really like if you can dream it, you can build it. But for, like I said, a token bridge is going to be the very first application built on Optics. Actually, to be honest, the very first application, which is already deployed on our testnet deployment of Optics, is a cross-chain governance protocol that I designed that governs the upgradability portion of our smart contracts across chains.
Oh, wow. Nice. Mm-hmm. Okay, what does it actually look like? So is this, you talk about a bridging protocol. Is the idea here that you would like burn on one side, mint on another, lock on one side, unlock on another? And also, is there any sort of central body where this is going through?
Yeah. So is there a central body? No. So the way that Optics works is a one-to-many communication protocol. So messages are sent on one chain, and the same mechanism for sending a message on one chain is used to basically send that message to any number of chains.
Okay.
And it's designed to be a sort of modular structure, which is easy to deploy on subsequent chains. And as soon as you deploy Optics on a new chain, it automatically hooks into this mesh of communication between different chains. So again, that's sort of designed to be more flexible, more generalized. And now if we're talking about token bridges, the specific dynamics of a token bridge, there's kind of the canonical token deployed on its local chain, its native chain. And that canonical token, obviously the point is that you can kind of send a representation of that token to another chain. And without inflating the supply and with always a guarantee that you can receive the canonical token on the native chain back if you were to send those tokens back. So that's basically, I can go further into that, but
so that's the promise, basically. That's like what it. But in terms of this mint, burn, lock, unlock, it's sort of optional. It depends on the bridge.
So the way it works is the native token is sent to the bridge router. That's the ZAP, the cross-chain application. When a native token is sent, it's held in escrow in the bridge.
So locked. That's the way I'm using this terminology.
Locked. Okay. It's locked on that bridge. Yeah. Then that bridge will send a message to the chain, the destination chain. On that chain, it will deploy a representation token.
Oh, like a synthetic. So is it kind of like a mint?
It deploys a representation token and mints those representation tokens on the chain. If you were to then send the tokens back, it would burn those tokens, send it to the native chain, and unlock them.
Got it.
Exactly.
So it's that combo.
Exactly.
I was always taught it sort of as two paradigms: mint, burn, lock, unlock. But here it's lock, mint, burn, unlock.
Exactly. And the interesting thing as well is that this isn't just a one-way street, right? It's not just native chain to non-native chain. What you can actually do is, like, if I were to send those representation tokens to a third chain, right, that would still represent the same native token, right? So
it could still be claimed on that native token potentially.
Right. So what you could do is lock, mint, burn, unlock.
Okay, cool.
You know what I'm saying?
Yeah.
So it's a super flexible, like, it can go in between all these different chains pretty seamlessly.
You said this is more of a net and not a like hub spoke model, because is that how most of these bridging things work a little bit more?
So the communication channel itself is 100% a hub and spoke model.
Okay,
but
it is.
What we can do is we can build up a web of these hub and spokes. So we use maybe the Celo mainnet as a home, and then we have maybe Ethereum mainnet as a replica. Maybe we could set it up as a Polkadot's another replica. You could have Ethereum be a home, and in this way you can have bidirectional communication.
Cool.
Between the different
so
blockchains.
Like a combination then.
Exactly, because at its core, the home sends messages to the replicas, and then you have to set up another home to send messages the other way.
So cross-chain messaging is necessarily unidirectional. So if you look at a single chain, it's a hub and spoke. But if you look at the system, each spoke is also its own hub.
Oh, wow.
Does that make sense? So it's an end-to-end.
Okay.
In my mind, I call it a mesh. Like, it forms this mesh of hub spokes, and each spoke being its own hub spoke.
Yeah.
Cool.
And maybe the technical definition is the communication between two blockchains would be dual simplex.
Got it. This is done, as I understand it, primarily with smart contracts, right? So this is smart contracts that live on each chain. I want to understand a little bit about how these actually work and what even like development of smart contracts like this look like.
Yeah, absolutely. So Optics has an on-chain component and an off-chain component.
Okay.
So the on-chain component is sort of my specialty, what I've been building. The off-chain component is more Connor's wheelhouse, especially there's a lot of infrastructure work that goes into that, right?
Massively distributed system, so.
Yeah, exactly. Complicated distributed tracing is necessary, observability, all that good stuff. But the way that the sort of journey of a cross-chain message, right, is it's triggered on-chain.
Yep.
That transaction is sent to an on-chain smart contract. Our smart contracts maintain a Merkle root of the messages that have been included on that chain. Then that's where the off-chain agents come in. First, the updater will actually sign a message notarizing that Merkle root.
Okay.
And what that does is it gives you essentially a way to prove to the replica chain that this update was included on the home chain. So that's the first time an off-chain agent comes in, is to notarize.
Okay.
Then an off-chain agent will come, relay that notarized root to a replica chain, submit it to the on-chain smart contracts. And then that's when the time lock begins. There's a fraud-proof period. And then the off-chain agents, again, come in to trigger the execution of the smart contract on-chain.
Cool. So what is this off-chain agent, actually? Like, what does that mean?
Yeah, great question. Basically, the kind of novel innovation here is we don't have to implement a full light client in a smart contract on-chain. And it allows us to kind of move all of the verification, all of the processing of these messages to the off-chain agents. And so there's maybe, I think, 4 or 5, updater, watcher, processor. They all got their kind of different names to describe what they do. And all they're doing is they're calling methods on these smart contracts and kind of facilitating the messages moving around.
Yeah.
Where do they live?
They live in the cloud. They're on on somebody's computer.
But they're not a decentralized entity. They are like a...
So, so a distinction that I love to make is that Optics is standard, right? So this is a design for how you might pass messages across chains. Our team, which designed Optics, has also built a canonical deployment, basically, of these agents. So we've written the code for these agents. We're also working on making it really easy to deploy these agents. It's all open source.
Yeah.
We want other people to be able to deploy their own agents if they should so choose, set up their own cross-chain messaging channels. So we have written and deployed canonical implementations of both the smart contracts and the off-chain agents. But you could implement Optics. You could implement your own version of Optics.
Open source.
Yeah.
Anyone can basically find that and do it themselves. Would an entity do that? Like, would a company or a blockchain or an application want to run their own off-chain agents?
You very well might. It kind of depends on what your needs are really, and how high touch you want to be in the cross chain, and basically setting up this communication channel.
Got it.
If you are lazy or just want to kind of do it quick and dirty and cheap, you can use our existing written, deployed, maintained version, or you could again fork it, write your own version. It's almost like if you think of like Optics, like Ethereum, there's different clients that implement it, Geth and Parity, for example.
Okay, it's like...
So it's like we've written Geth, we've written a canonical implementation of the standard, but other people could write their own.
Cool.
If they wanted.
Nice.
Yeah.
What would you say sets Optics apart from existing kind of bridge infrastructures?
It's very gas efficient. That's the big thing. It's optimistic. So all of the processing happens kind of mostly off chain, and it kind of ends up being 95% cheaper in terms of gas.
Cool.
Which is kind of a great novel improvement over maybe existing bridging technologies. Yeah.
Yeah. So as Connor touched on earlier, the crucial sort of differentiator in the design of Optics is that Optics doesn't require running a light client on chain. And that's very expensive. It's also difficult to implement, and it also makes it much harder to deploy that protocol on additional chains. It requires significant additional development and energy, really, to...
Is that because every chain would require a different kind of light client?
Correct, yes.
But even if they're EVM compatible?
Well, unclear, actually. That's a good question. I think there are certain EVM compatible chains that have differences, right? That, like, for example, Celo is an EVM compatible chain, but it's a proof of stake chain.
True.
Whereas Ethereum is currently proof of work. So the light clients are validating this consensus mechanism.
Yeah.
So Celo has a different consensus mechanism. We took Geth and we ripped out consensus and replaced it. So yes, it would be even though it's an EVM compatible chain, it would require a different light client.
I see.
Yeah.
And so Optics doesn't have light clients.
No.
And is it the smart contracts that act as the light client? Like how does, yeah.
Yes, so this is kind of the big difference in terms of optics as a standard for cross-chain communication, is that we've taken a different security model, and you can think of the trade-off space a little bit almost like a ZK rollup versus an optimistic rollup. Not saying that the design, that's the difference in the designs, but in the trade-off space. So a ZK rollup is proving correctness proactively.
Yes.
An optimistic rollup is giving anyone the opportunity to prove fraud.
Yes.
And so similarly, a ZK rollup is significantly more expensive to run and to run, whereas an optimistic rollup is a lot cheaper. And it has this trade-off in the security model, right? So, like, fraud can be committed on an optimistic system, but there's economic disincentives to do so.
Totally.
Your fraud essentially probably wouldn't work. It wouldn't work because fraud would be proven, it would be blocked, and you'd lose money.
Yeah.
So that's the sort of difference in the security model, and that's the trade-off space we're working in.
Cool.
Yeah.
What do you think this means for Celo, but also what does it mean for the general ecosystem? Something like optics. What does that mean for people?
I mean, we are so excited to just be enabling more developers to come to the Celo ecosystem. We are having a bunch of really cool movement around decentralized exchanges on Celo. So I know I'm personally excited about just having more tokens. Sky's the limit there.
Yeah.
Cool.
I mean, in the past, it's been really complicated and expensive to set up any sort of cross-chain messaging protocol. Optics is making it easy, cheap, fast, simple, modular. You can also just plug into existing deployments of this system. So what I'm excited about is getting developers' minds churning about what they can do in this cross-chain environment. And that's what I want to accomplish with my workshop on Wednesday, is to really get people understanding how they can build on top of this themselves.
Cool.
And I've tried to make that easy by providing a lot of examples, documentation, etc.
Nice.
So,
Do you know if that's being filmed?
I think it should be
Hopefully,
filmed.
maybe by the time this video comes out, there's also a video for that.
Yeah, there
Maybe
will be.
there's a way to link it.
Yeah.
I have kind of one last question, which is, as I understand it, most of this is, it's smart contracts written in Solidity. So it's for EVM compatible chains primarily. But is there or it isn't? Oh, tell me.
Yes. So
explain.
The current sort of, I've written currently the canonical implementation of the contracts in Solidity.
Okay.
But the contracts can be written in any smart contract language.
Got it.
We will be writing them in Rust for other chains. We'll be writing
Cool.
them in other smart contract languages for other chains. And kind of the point of how we've implemented this is it doesn't use special cryptography that's not available widely on different chains.
Nice.
It can be implemented on other chains easily.
Very cool.
Yes.
Do you know timeline-wise about that? Like Solidity's now, Rust is soon?
Yes. So timeline right now, we're out on testnets right now.
Okay.
We are actively shipping into testnets presently. So we're iterating. We are working out the kinks actively, and we are working on it.
Cool. All right. Thanks. Thanks so much for the interview.
Thanks for having us.
Thanks for watching.